Hello students, welcome to the 10th part of Unit 7 Nitrogen Compounds. In this video, we will discuss some carbonic acid derivatives. This is the structure of carbonic acid H2CO3, that is the molecular formula. In carbonic acid, two of the OH group has been replaced with NH group, that is the structure of urea. So the first derivative we will discuss is urea or carbamide. Urea is a diamide of carbonic acid, as I already mentioned, and it is the end product of metabolism of proteins in our body and is excreted in urine. It is one of the best nitrogenous fertilizers, and drugs like barbiturates are manufactured from urea. I am just discussing about the importance of urea. And it is a white crystalline solid having melting point of 132 degrees centigrade. It is soluble in water and alcohol, but it is insoluble in ether, chloroform and benzene. Now we will see how the isolation of urine is carried out. To isolate the urea, we have to concentrate by evaporation and treat it with hot oxalic acid to precipitate urea oxalate. So urine sample has to be evaporated for concentration and is treated with oxalic acid to precipitate urea oxalate. The moment we add oxalic acid, urea oxalate will be precipitated. These crystals, urea oxalate crystals, are filtered and boiled with aqueous suspension of calcium carbonate for liberating urea in solution and precipitating calcium oxalate. This oxalate part will precipitate as calcium carbonate, and the remaining urea will be in aqueous suspension. It will be in aqueous form. This calcium oxalate is filtered. Once we filter the calcium oxalate, the remaining filtrate is containing our urea, and that is evaporated to dryness, and this residue is recrystallized from alcohol to get pure urea. Recrystallization from alcohol will give the pure urea. So this is the method of isolation of urea from urine sample. Now we will see the laboratory scale preparation of urea. Urea is prepared by treating phosgene with ammonia. We get urea. Otherwise, we can treat ammonia with ethyl carbonate, also give the urea as the product. So this is the two method reaction of ammonia with the phosgene as well as ethyl carbonate. We get urea as the product. Now, in large scale preparation, this is only laboratory scale preparation. In large scale preparation also we have two methods. The first one is liquid carbon dioxide is treated with liquid ammonia. We mix liquid carbon dioxide and liquid ammonia in silver lined autoclave to get ammonium carbonate. If you mix these two, we get ammonium carbamate, and this is heated. This ammonium carbamate is heated at 130 to 135 degrees centigrade under about 35 atmospheric pressure to get urea. So the ammonium carbamate is heated to 135 degrees centigrade and adjust the pressure at 35 atmospheric pressure. We get urea as the product. The next method is the reaction of calcium cyanamide with sulfuric acid. It will give cyanamide, and this cyanamide is hydrolyzed. Hydrolysis of this cyanamide will give urea. So this is the two method of preparation of urea in plant scale or in industrial scale, large scale preparation of urea. We have two methods. So these are the two methods of industrial preparation. Now we will discuss the chemical properties of urea. Let us start with action of it. What happens if we heat it? So if you heat the urea, you are taking some sample in a spatula, and if you heat it, it will convert to biuret. The two molecules will combine and will liberate ammonia, and we get a white solid biuret. And this aqueous solution of biuret, that is soluble in water, solution of biuret is treated with 10% sodium hydroxide and a drop of copper sulfate solution. If you add some 1 drop of copper sulfate, a violet color will appear. This is known as biuret test, and this test is also used to test any compound containing peptide bond. CONH bond is known as peptide bond. So if to detect the peptide bond in any compound, we can use this biuret test. If you heat it, it will convert to biuret, and just add some sodium hydroxide and a drop of copper sulfate, it will give a violet color. So this test is being used in our organic laboratory experiments to detect the presence of urea, this bio test is being used. You will be doing this in practical. So next reaction with while heating is if you heat till 170 degree, you will get cyanic acid, and this cyanic acid trimerized to cyanuric acid, and that will get tautomerized to cyanuric acid only ketopform and enol form. So this is a keto-enol tautomerism. Ketoform will contain a carbonyl bond, C double bond O, and enol will have a COH. So tautomerism means we are just changing the position of hydrogen between this oxygen and nitrogen. In cyanuric acid we have C double bond O, NH bond. In enol form we will have COH and doubly bonded to nitrogen. This hydrogen and oxygen has been exchanged. The position of this hydrogen is changed, and the position of double bond also changed in keto-enol tautomerism. Now the action of heat you have discussed already. Now how is the basicity of urea? Once we react with any acid, it will form the stable salt. The urea is reacting with nitric acid, we get urea nitrate. That is white crystalline urea nitrate is formed while reacting with nitric acid. Same way, if you react with oxalic acid, urea oxalate will form. That is also a white crystalline solid. Now the third reaction is hydrolysis. If we just hydrolyze the urea with water, we get carbon dioxide and ammonia as the byproduct. The enzyme urease can also bring about the hydrolysis. If we react with the enzyme urease, the same hydrolysis reaction will happen. Now the next reaction is action with nitrous acid. Nitrous acid is NaNO3, NaNO2 will mix with HCl, we get nitrous acid. So reaction of urea with nitrous acid give carbon dioxide, nitrogen gas and water. Action with alkaline hypohalate. This is important reaction. When treated with alkaline solution of sodium hypobromate, urea evolved nitrogen gas quantitatively. Means this nitrogen we can quantitatively analyze. Then this is the basis of hypobromate method for estimation of urea, and is particularly useful in determination of urea in various body fluids. So to detect the presence of, or to quantitatively detect the presence of urea, we can use this method. Just react with sodium hypobromate and definitely we get nitrogen gas. This nitrogen gas can be quantified by some methods, and we can indirectly we can detect we can estimate the amount of urea present in our sample. That we will discuss later, the method of estimation. So this is a reaction with sodium hypobromate. Next reaction is action with hydrazine. Urea is reacting with hydrazine, we get semicarbazide. This semicarbazide is another carbonic acid derivative we will discuss in the next section. So this is the method of preparation also. Here we are discussing the reaction of urea with hydrazine, we get semicarbazide, and while we discuss semicarbazide, this is one of the methods of preparation of semicarbazide. Next reaction is action with malonic ester. Malonic ester is reacting with urea. It will condense with urea, diethyl malonate condense with urea to form malonyl urea, which is used in preparation of medicinal hypnotics like luminal and veronal, etc. These are some medicines using hypnotics method. So this is one of the medicine that can be prepared by using urea by reacting with malonic ester. Next reaction is action with acid chlorides and acid anhydride. In reaction with acetyl chloride will give N-acetyl urea. It's a uricide. This uride, acetyl chloride reacting with urea will get N-acetyl urea. Next reaction is action with formaldehyde. While reacting with formaldehyde, urea gives a resin, that is urea formaldehyde resin by polycondensation. Polycondensation between urea and formaldehyde will give, in weakly alkaline condition, we get urea formaldehyde resin. So this is the reaction. This is urea and this formaldehyde. We get monomethylurea in the first step, and again we take the excess amount of formaldehyde, we get a dimethyl urea, and while continuous polymerization with more urea and formaldehyde give the final three-dimensional resin structure. This is an important resin. It's a colorless and possess good tensile strength and hardness. It is water resistant and oil